Hello, my name is Barney Warf, and it is a pleasure here to talk to you about the changing nature of proximity, particularly as viewed through the lens of time-space compression. This is a topic that has intrigued me for a long time, so I want to share with you some thoughts about what time-space compression is and its implications for studying geography. Time-space compression refers to the shrinking of geographical distances through improved transportation and communication technologies. And these have all sorts of economic, social, and perceptual effects. I want to begin with an observation that strikes many people as rather odd. Time and space often appear to us as natural, that is, as something outside of society, as if they're given, not made. But one way of looking at these is to argue that time and space are actually produced by a society. They are made, not given, that these are social constructions. This is a way of bringing time and space from the outside of social analysis, where they look like containers, and bringing them inside. And this means that we can interpret and experience time and space in a variety of different ways. Societies organize time and space and give meaning to them in a wide variety of ways. Here's a famous picture called The Persistence of Memory by Pablo Picasso that speaks to this notion, and maybe a more digitized version as an update. Time is plastic in the sense that we make time, find time, kill time, waste time, save time, for example. And we can say much the same thing about space. Right? Here are just some examples of how we use time in different ways. We have a geologic time scale that often stretches over millions or hundreds of millions of years. And that's quite different from the time that we might use to study economic time, like punching into your job, for example. In many pre-industrial societies, time is viewed cyclically, that is, with cycles that repeat themselves, such as illustrated over here by the Mayan calendar on the left. The idea of linear time largely came out of the Industrial Revolution, time as only having a past, present, and future. Or we could differentiate between kairos time, time that we spend without knowing that time is going by, like when you're enjoying yourself. Time flies when you're having fun, versus chronos time, when you're acutely aware of time. The same thing holds for space. And I begin with a famous debate between two 17th century European geniuses, Isaac Newton in Britain and Gottfried Leibniz in Germany. They argued over many things, like who invented calculus, but they also had a long debate about the nature of space. Newton argued that space was absolute. It was a thing that was fixed, given, and independent of anything in it. Whereas Leibniz argued for a relative view of space. Space could only be measured in terms of the things that were put in it. So it's this Leibnizian view that I'm going to be using today. Relative space means that we measure travel times in terms of time or cost. For example, here's a map of Seattle showing these lines of equal transport time from downtown called isochrones. When we standardize the isochrones, we get a distorted view of the geographic space of Seattle. When we study relative as opposed to absolute space, we note that the distances between places will change. Usually they decline as transportation technologies get better. For example, in this diagram, we see the number of minutes to go between Edinburgh and London in Great Britain over about a 3-century period. And you can see that there have been dramatic declines in the time necessary to travel between them. But the absolute distance between them remain the same. Here's another example. With the introduction of the railroads, it became much easier to go from London to other parts of Britain much more quickly. London, as it were, was enfolding Britain within its kind of activities through the stretching out across the rail lines. The Industrial Revolution marked the first major wave of time-space compression under capitalism. It led to enormous increases in the velocity of both transportation and communications. Karl Marx called this process the annihilation of space by time. And he was right in the sense that time quickly became much more important than space in understanding how social and economic activities unfold. The steamship, for example, one of the applications of steam power to transportation, greatly reduced the travel times across the North Atlantic Ocean. It used to take months to travel by sail, but with the introduction of the steamship in the early 19th century, this travel time was reduced to a matter of weeks. Railroads did much the same thing on land. They made traveling over long distances very fast. Right? So here, for example, we see travel times from New York in the early 19th century, when it took a long time to get anywhere, and then by the mid-19th century, when the rail lines allowed people to get out into the Midwest much more quickly than they could before. To give a sense of how disorienting this process was, I call here on the German poet Heinrich Heine, who observed in the mid-19th century, what changes must now in our way of looking at things occur? Even the elementary concepts of time and space have begun to vacillate. Space is killed by the railways, kind of echoing Marx's notion of the annihilation of space by time. The telegraph did much the same thing in the domain of communications. Developed by Samuel Morse in 1844, the telegraph was the first form of telecommunications. Up until the telegraph, information could not move any more quickly than the human body. Messengers had to carry messages, for example. But the telegraph freed information from its reliance on the human body. It allowed information to travel at almost the speed of light. And soon there was an international line across the Atlantic, and then a whole network of telegraph lines in the late 19th century, sort of the Victorian internet, if you will. In the late 19th and early 20th centuries, there was a second great wave of time-space compression. This really sees the birth of the modern world, a world that was changing incessantly, rapidly, and giving rise to new interpretations of time and space. A whole slew of new technologies contributed to this process. Photography, for example, allowed people to capture images of distant places and bring them home, and where they were reprinted in magazines like National Geographic, allowing people to read and view faraway places for the first time in large numbers. Right? The stopwatch made it much easier for people to keep track of time. And as more people could keep track of time, they were expected to know the time and to show up punctually. All of these are aftershocks of this wave of time-space compression. The bicycle allowed people to ride much more quickly than before, and it expanded commuting fields in urban areas. It changed the everyday lives of the middle class, allowing young lovers to run away and escape their chaperones, for example. And then when Alexander Graham Bell unleashes the telephone in the mid-1870s or so, it becomes the instrument that wields together people over long distances, allowing them to keep in touch with family and friends, and undoing the close-knit face-to-face bonds that used to define what it meant to live in densely populated urban neighborhoods. In the early 20th century, Albert Einstein comes up with the theory of relativity. This greatly changes our scientific understanding of time and space. They were no longer the fixed, immutable, static phenomena that Newton had painted them to be. Rather, time and space were malleable and changed depending on the position of the observer. So I say this to drive home the point that these space shrinking technologies, these information and transportation technologies, not only have social and economic impacts, they also have psychological and perceptual ones. Time-space compression is as much a psychological phenomenon as it is a social and economic one. In the 20th century, yet other waves of time-space compression began to redefine the meaning of proximity. The automobile, for example, allowed vast numbers of people to move with unprecedented speeds. My father tells me that when he was a young boy in the 1920s, young men would boast that they had been in cars over 60 miles an hour, and learned doctors said the human body was not designed to go more than 65 miles per hour. Little did they know. In the 1950s, the federal government started the National Highway System, the largest project Uncle Sam ever undertook. It developed a whole network of highways that sutured together America's large cities. It made it much easier to go from city to city and vastly increased the economic and social intercourse between them. Today, we find state-of-the-art transportation technologies like high-speed magnetically suspended trains, such as the TGV in France or the Shinkansen in Japan. These move very, very rapidly, again, connecting places together with one another. And air travel in the 20th century likewise had enormous social, economic, and perceptual impacts. This map illustrates how long it takes to get to anywhere in the world, right? And you can see that these places that are very dark are still rather remote despite the presence of air travel. This is a very famous diagram that illustrates the shrinking globe that is virtually synonymous with time-space compression. We see that as transport speeds increased, the globe got smaller. And in the 20th century, first the jet propeller and first the propeller airplane and then the jet airplane began to shrink spaces to an unprecedented degree. Today, much of the world economy can be characterized as a necklace of globalized city regions that are much more connected to one another through daily airplane flights than they are to other places in their own economy. So air travel has revolutionized the time-space structure of the world system. In the late 20th century and in the 21st, we see yet another round of time-space compression, this time closely associated with the ongoing process of globalization. Supply chains internationally, for example, have become very, very complex. And current globalization, above all, is defined by the presence and use of digital technologies. Telecommunications have erupted and created all sorts of new technologies that shrink space almost to the head of a pin. Satellites, for example, produce instantaneous time-space compression within the footprint of a satellite. And very large satellites can have a footprint that covers up to a third of the world's surface. In the 1980s, 90s, and then the 2000s, many fiber optic lines were laid across the world's oceans. Fiber optic lines transmit information in vast quantities at the speed of light. These became the backbone of the internet and the nervous system for the global economy, where vast amounts of information and finance moves through speed in a syncopated dance at the speed of light. So my point is the internet, cell phones, social media, text messaging, all of these are just the latest story in a long series of stories that define the historical geography of time-space compression. And throughout, we get these changing networks of centrality and peripherality that have always characterized the mutating geographies of capitalism. This raises the question, is geography become irrelevant? We hear from people like Thomas Friedman that the world is flat, that location doesn't matter, that that distance has died. But the reality is more complex than those kinds of simplistic assertions. Geography very much matters. It has not gone away. It has just changed in its nature and in its scope. For example, unlike the flat, frozen, static surfaces of absolute space, the way in which many people think about geography, relative space tends to be much more complex. It's unstable, full of wormholes that allow us to traverse long distances almost instantaneously. A cell phone call or an email message is an example of a wormhole. Right? There are different ways of thinking about relative space here. Much of conventional geography was conceived in terms of topography, the shape of the world's landscapes, as illustrated by this topographic map. But I think a better metaphor for understanding relative space is topology, the mathematical branch that studies shapes. And in a topological surface, it's not flat and static, but twisted, folded, and looped together by these strange kinds of spatial organizations. I also like the metaphor of geography as origami, the Japanese art of paper folding. In many ways, contemporary globalization and its technologies fold and refold geographies across the space of the world, constantly forcing us into new spatial configurations that are often very difficult even to perceive. So all of this illustrates that geographies are constantly coming into being, forever under construction, constantly changing the nature of proximity, of the meanings of here and there, or near and far. And we need to view geographies in this light if we are to comprehend how complex and rapidly changing the world has become today. Thank you.